We'll start with UDP. UDP actually contains only 5 separate fields: a 16-bit source port and a 16-bit destination port, a 16-bit UDP length field, and a 16-bit UDP checksum field, which is used for calculating the header to make sure the header is received intact. And then the layer 5 through 7 data. This information would be passed down to IP, where the IP packet header that we have looked at earlier in the series would be added to this. There's a whole lot of intelligence here. Literally everything must be maintained within a single packet for this application. The application is responsible for any sequencing that must take place or any data recovery that must take place. What is very important is the difference between the source port and the destination port. If we look at our port values again, these port values are what are known as well-known ports. Well-known port ranges exist between the ports 1 and 1024. Anything above 1024, that is 1025 through 65,535, are known as high-order ports. Well-known ports are ports that are assigned by originally the IANA and now by the ARN organization. These port values are actually well-known ports that identify an application. If I look at FTP, for instance, I have got an FTP server for file transfer running on the internet. By default, the FTP service on the server is listening on port 21. So if I'm a client attempting to gain access to FTP, I will put in my FTP client the IP address of that target FTP server. Because it is an FTP request, an FTP client request, it will automatically make the destination port 21 towards whatever IP address will be handled at layer 3. I will also put in a 16-bit source port, which will be any number from 1025 through 65,535. This port value is actually going to be used for return trip traffic to my client. So anytime the server side is talking back to the client, this is going to indicate what port value was listening for return conversational traffic for this session, and that's the purpose for those high-order ports. Those high-order ports also allow you to have session-based multiplexing, where you can have multiple sessions outbound from your computer because your first session would be 1025. Your next session would be 1026. Your next session would be 1027, and so on, effectively allowing you to have up to 64,000 outbound sessions from your PC at any given time, which is fantastic. That's the kind of idea behind the UDP header and the way that ports are used. Now, the ports are going to be used in much the same way with the TCP header. You'll actually notice that 16-bit source port and a 16-bit destination port are going to be used, but in addition, TCP has a lot of other information that is used to maintain some of its advanced connection-oriented properties. Some such properties are a 32-bit sequence number and a 32-bit acknowledgement number. An acknowledgement number is used to verify that data is being received on both ends. A sequence number indicates the sequence of data as it is being sent from a local host. One of the things that you will see as we proceed through TCP conversations is that information, which is sent with a sequence number, is going to be acknowledged at the other end.